B says evaluate the difference quotient for x sub 0 equals 1 and delta x equals 2. So in part B, we're saying let x sub 0 equal 1 and let delta x equals 2. If we just plug into this formula for the difference quotient, what we get is delta y over delta x, in that case, is equal to 2 minus 2 times 1 minus 2. So this would be equal to minus 2. Okay, that would be the value of the difference quotient. Okay. Sketch the function f of x and illustrate your answer in part B. So in part C, we're to sketch the function. Now, anytime you have an equation like this, and the highest power is 2, then this is going to be a quadratic function. And when you graph these quadratic functions, they always look like either they're U-shaped or they're an upside down U, one or the other. Whether it's U-shaped or upside down U depends on the sign of that coefficient. Okay. If it's negative, if that coefficient on x squared is negative, then it is going to be U-shaped. If it's positive, then, excuse me. In this case, it's minus x squared, it's negative. So actually that means it's going to be upside down U. Okay. If it were positive, then it would be U-shaped. Okay. So the way you can kind of figure out this, if you forget that, when x goes to infinity, what's going to happen to the value of y? As x goes to either infinity or minus infinity, what's going to happen to the value of y? Yeah, it's going to, as x approaches infinity, y will approach minus infinity. So it's turning down as x gets bigger. Or as x approaches minus infinity, y is approaching minus infinity. So then you know it's going to be upside down u. Okay, so we know it's an upside down u. We know at the origin the value of y is going to be 0, so it goes through the origin. One more thing that will be useful in graphing this, and this is getting ahead of ourselves a little bit, but that's okay. Suppose you take the first derivative of this function, f prime of x. Here, f prime of x is equal to what? Those of you who know your rules of differentiation. William? It's 2 minus 2x. Suppose we want to know where the slope is 0, where the slope of the function is 0. And then we would just set this first derivative equal to 0. And what we would get is x sub 0, the critical value is equal to 1. So we know the slope of the function is 0 at x equals 1. So now we have a good idea how to graph the function. If you graph the function, it's just going to look like this. It goes through the origin, and let's make sure we label our axes. It goes through the origin. It's upside down u. So it's going to look like, have that shape. Okay, and we know at x equals 1, the slope of this function is 0. So that's where the maximum value of the function is. Okay, and if you plug in x equals 1 into the original function here, you get 2 minus 1. So the height of this function right here is 1. The maximum value of y is equal to 1. And that occurs by coincidence at a value of x equals 1. Okay. So this would be the origin right here, and this would be the value x equals 2. Okay. So actually, one of the useful things that comes out of calculus, one of the very useful things that comes out, is curve sketching. It tells us how to sketch curves and how to identify the maximum and minimum in the functions. Okay. So let's see what we'll be doing in part C. We're sketching the function. We've done that. And illustrate your answer in part B. Okay, that we have to do that. In part B, we found that the value of the difference quotient was -2 for this case right here. If x is equal to 1 and delta x is 2. So we found that difference quotient is -2. What does that mean in terms of the graph? Well, let's illustrate that. Suppose we start at this point right here. That's our initial value of x. X equals 1. We let x increase by 2. So if we let it increase by 2, we'll be up here at 3. Now, if we go down to the function right here at x equals 3, the value of the function at x equals 3 is what? What is f of 3? Well, it's 2 times 3 is 6 minus 3 squared is 9 minus 3. So this value down here, -3. Okay. All right, now, what is the average rate of change of y with respect to x over this interval as x goes from 1 to 3? Well, what you want to do is connect these 2 points with a straight line, and the slope of that straight line is the difference quotient, is the geometrical interpretation of the difference quotient. Look at the slope of this line right here. What is it? Well, the rise is actually, you're going from 1 to -3, so this delta y is -4. The delta y value is this value right here. And this is equal to a -4, because you're going from y equals 1 to y equals -3. What is the horizontal distance? That's your delta x. And your delta x is 2. What is the slope of this line? The rise over the run? -4 over 2, -2. So this slope is -2. The slope of this line gives you the average rate of change of y with respect to x over this interval as x goes from 1 to 3. Okay, so that's the geometric interpretation of the difference quotient.